mathematicians. Today we are going to talk about rectangles. Rectangles are a specific type of parallelogram. So they have the same rules we have been talking about. Opposite sides are congruent and parallel. Opposite angles are congruent. Consecutive angles, meaning they are on the same side, are supplementary. And diagonals bisect each other. We have two new rules that are specific to rectangles. The first is all angles are 90 degrees, or right. So there are 4 angles in a rectangle. All angles are right or 90 degrees. Those 4 corners in the rectangle have to be 90 degrees. The second one is the diagonals are congruent. So not only do the diagonals bisect each other, but the diagonals have the same measurement. Remember, these are specific to rectangles. So using that information, let's piece that together and find some missing pieces. So, I am given this side is 10, this side is 24. So QR is right here. What would that be? 10. SR is down here. It's opposite, so it would be 24. Okay. Next, it wants us to find SQ. Okay. It wants us to find SQ here. So I have 10, 24, and SQ. Well, I don't know anything else about that to help me out. So what I'm going to have to do is I'm going to have to use the Pythagorean theorem to find that. Okay. So to use the Pythagorean theorem to find SQ, SQ is the diagonal. So what you're going to do is you use a side squared, plus the other side squared, equals the diagonal squared. We'll call it C squared. Okay? So a side squared plus the other side squared equals the side squared plus side squared equals diagonal squared. Now you need to solve. So enter this in on your calculator. And you get 676. And I need to get rid of a squared. How do you get rid of a square? Square root both sides. So take the square root, and this diagonal equals 26. Okay, so side squared plus side squared equals the diagonal squared. That's the Pythagorean theorem. So if SQ here is 26, what do you know about PR? Well, it's a rectangle. All diagonals are congruent. So if that one's 26, this one's 26. Okay. And lastly, QT. What do you know QT? It is half of the whole thing. So if the whole thing is 26, what must QT be? Divide 26 in half and you get 13. Okay. Try this next one on your own. Let's see how you did. So I'm given this piece here is 15 and this side is 27. I want to find AC, so the whole thing. Right? Well, if the part is 15, what's this part over here? 15, so the whole one is 30. The whole diagonal is 30. BD is the other diagonal, so if this diagonal is 30, This diagonal is 30. Next, it wants me to find BE. What do you know about BE? It's half of the full diagonal. So half of the full diagonal would be 15. Next, it wants me to find AB. How did you find AB? It's opposite DC, so AB must be 27. The next one might have thrown you off. It wants you to find BC, so it wants you to find one of those sides. So this is where you have to use the Pythagorean theorem again, but a little backwards. So I have a side, 27 squared, plus the other side, which I don't know, squared, equals, this time what is the diagonal? 30 squared. So side squared plus side squared equals diagonal squared. So this time to solve, what is 27 squared? 729. And 30 squared? 900. What do you do to solve for x? Minus 729 on both sides. X squared equals 171. And how do you solve for x? Take the square root. So BC is about 13.1. Okay. So side squared plus side squared equals diagonal squared. Nice job. Let's take a look at this one. We are given DB, so the whole thing is 42. AD is 26. And DAE is 52. So that's this angle right there. Find AC. Well, this diagonal was what? 42. So what must this diagonal be? 42. The diagonals have to be the same. EB then is half of the diagonal. So what do we do to find EB? 42 divided by 2 is 21. How do you find BC? It's opposite, so BC must be 26. And AB. This is just like the example we just did. I know a side and the diagonal was what? 42. So I'm going to use Pythagorean theorem. Side squared plus side squared. And since I don't know that side, I put an X, equals diagonal squared. So it's really important that the diagonal piece goes here. So it's side squared plus side squared equals diagonal squared. What is 26 squared? 676. And 42 squared? 1,764. How do you solve for x? Subtract 676 on both sides. 1,088. And how do you solve now? How do you get rid of that square root or squared? Take the square root. X equals about 33. 32.98, so about 33. So use that Pythagorean theorem. Next, let's talk about some angles. A, D, C. What do you know about a corner of every rectangle? It must be 90. A, B, D. Okay. A, B, D. So I need to find out some more information in order to find that piece. So I need to find some other angles. Well, let's start looking here. If this one's 52, what must this one here be? 52, alternating interior. Okay. I can then find this piece here. Each angle must be 90, so 90 minus 52, 38. I still need to find ABD. Since these two sides are the same, because we know that bisectors are the same length and then they're cut in half, this is an isosceles triangle. So if this angle is 38, what must this angle be? Also 38. So our angle ABD is 38. Next we must find BCA, which we already talked about. If this one's 52, this one here is 52. And lastly, DEC, so this angle right here. Well, if this one's 52, they're isosceles triangles because this piece equals this one. What's this angle must be? 52. So I can either find this one and make a straight line to find here, or if I look up here, 38, 38, how do I find this missing angle? 180 minus 38 minus 38. And this one here would be 104. What do you know about these angles? They are vertical, so this one must be 104 as well. So you're going to have a lot of triangle properties coming into play there. Let's take a quick look at this one. MO is the whole length. PR is half. Okay. I know that these are the same, so two of these must make the whole thing. So 2 PRs, so 3y minus 5 plus 3y minus 5 must equal 4y plus 12. PR is half, so 2 of them equal the whole thing. You can then solve for y, plug it back in to find the missing pieces. Let's take a look at this one. We have a quadrilateral with 4 coordinates, and they want us to tell if it is a rectangle. Go ahead and make a quick sketch of this. -4, -1. G is -2, -5. H, 4, -2. And J, 2, 2. Now I cannot assume anything looking at this. First of all, my picture is not perfect. We cannot assume anything. What we need to do is there's a few ways we can do it. We can first check if our opposite sides are parallel and perpendicular to here. So we're going to look at what to tell perpendicular and parallel. We're going to look at slope. And how do you find slope? Subtract the y's over, subtract the x's. I need FJ to be parallel, I should do these signs, parallel to GH. And then I have to make sure that it's also perpendicular to FG. So let's start finding a few slopes. FJ, -1 minus 2. All over, subtract the x's, -4 minus 2. -3 over -6, which equals 1/2. Next, we have to find GH. Subtract the y's, -5 minus 2. Subtract the x's, -2 minus 2. Oops, I used J. Shoot. So -5 minus -2. I was right on top, but on bottom I switched. -2 minus 4. There we go. That's a little better. Sorry, guys. So -3 over -6. That is also 1/2. So far I'm good. These are parallel. That's good. Next, you need to check, are these two parallel? So I need FG parallel to JH. All right. You need to check that and see what those two slopes are. So FG -1 minus -5, -4 minus -2. So I get 4 over -2, and that is -2. Lastly, check JH. JH, 2 minus -2, and 2 minus 4. Should get 4 over -2, which is -2. Perfect. These are parallel. Last thing you need to check is that these, in fact, make a 90 degrees. 90 degrees means they are perpendicular. What do you know about perpendicular slopes? Opposite reciprocals. So check, are these opposite reciprocals? Yes. And are these opposite reciprocals? Yes. So this, in fact, is a rectangle. So not only do you have to prove opposite sides are parallel, but these ones here are perpendicular. Last one, you can use properties of a rectangle and the reflexive property to write your proof. Nice job today, mathematicians.